Okay, this is part one on the solutions for the problems on test 2 of the fall 2013 APB physics course. Um, in this case, we have a set of vectors, and we're asked to convert those vectors into Cartesian form. So we're looking at finding these sides of a triangle right here. I'll call this side A and this side B. A is equal to the hypotenuse, which is 6.50, times we're looking for the adjacent side. Adjacent starts with the letter A. Cosine starts with the letter C. C is closer than S for sine, so we use the cosine function. Cosine 25 degrees. Plug that in your calculator, get about 5.89 to 3 sig figs. And if you take and look for the opposite side, B, that's opposite. Opposite starts with O. O is closer to S for the sine function, so we need the sine function. 6.50, again the hypotenuse. Sine 25 degrees. Punch that in the calculator, 2.75. If we now go to write the Cartesian form, A is equal to, we have this side, but it's moving in the negative x direction, so we need to put a minus sign to get the component. 5.89 I hat. And in the y direction, it's going up. That is the positive y. Right, we're looking at this as x and y. So that's the positive y, so plus 2.75 j hat. So that's the answer to problem number 1. Problem number 2. This time, again, we have an A and a B. I'll call this A, I'll call this B. This is X, this is Y. A, I'm looking at 12.5, but this time when I look for the trig function, I'm looking for the opposite side. So that means I should use the sine function. Sine of 15 degrees. So A is approximately 3.24. B is equal to 12.5 cosine of 15 degrees, because we're looking in B, we're doing the adjacent side. So B is approximately 12.1. So put those two together, and we have that the vector is equal to, I'm going in the positive x, so I need a plus sign to my A component, 3.24 I hat. I'm going in the plus y direction, so plus 12.1 j hat. So in this case, both of the signs were positive because we were in the first quadrant. Move to the next problem. So more of the same. Again, making an A and a B. There's a B. There's an A. Again, we're looking at X, Y. A, we're looking for the adjacent side, so 24.0. And we're looking at the cosine of 35 degrees, and that is 19.7. In B, 24.0 for the hypotenuse. We're looking for the opposite side, so we use the sine. And that gives us 13.8. So A is approximately, we're going in the positive x, so we get a positive 19.7 I hat, but we're going in the negative y, so we get a minus 13.8 j hat. That takes care of problem number 3. Problem number 4. There we go. So there's my A, there's my B. A is 76.5. We're looking at the adjacent side, so cosine of 48 degrees. So A is approximately 51.2. B is 76.5. We're looking at the opposite side, so we use the sine function. 48 degrees, so B is approximately 56.9. A, in this case we're going to the minus x, minus 51.2 I hat. We're also going to the minus y because we're in the third quadrant. So we have minus 56.9 j hat. Converting a vector into Cartesian form. One of the first things you have to do in a physics problem is break vectors into components. So a very essential thing to be able to do. Next set of problems. Problem 5. Write the following vectors in polar form. Okay, so now we're going the other way. We finished the physics problem type and we'll have to convert it back into polar form. So first thing to do is draw yourself a good drawing. There's my axis, X, Y. I'll change my pen color. So I'm looking at something like this, where I have an 8, a 12, and a theta, and some angle A. A is the square root of 12 squared plus 8 squared. That's just the Pythagorean theorem. And that's 14.4. Theta is the inverse tangent of the opposite side, 8, divided by the adjacent side, 12. And that gives me 33.7 degrees. So A is 14.4 at an angle of 33.7 degrees. And that takes care of that. All right, number 6, same sort of thing. Draw an axis. So this time I go over 21 in the negative and down 11. So there it is. So this is 21. This is 11. This is phi. The angle that they're actually looking for is generally this angle there. And of course, this side is A. A is the square root of 21 squared plus 11 squared, which if I punch my calculator gives me 23.7. Phi is the inverse tangent of 11 over 21, which gives me 27.6 degrees. Theta, however, is equal to 180 plus phi, which gives me approximately 208 degrees. So A is approximately 23.7 at an angle of 208 degrees. Problem number 7. All right, problem number 7, we draw an axis again. In fact, as long as I'm at it, I might as well draw a couple of them. There's X, there's Y, there's X, there's Y. All right, I'm looking at going over 15 and down 8, so I'm over here somewhere. Oops. And this is 8, this is 11, and this is phi. Alright, so the length A, which is that length there, by the Pythagorean theorem is 8 squared plus 11 squared. So we'll have to punch a calculator here a little bit. And I'm sorry I didn't do that right. Why did I get 8 and 11? That's my fault. I don't know where I got 8 and 11. I have 8. That's not 11. That's 15. Put that back 15. Alright, there we go. And that gives me that is approximately 17. Alright, and then phi is the tangent to minus 1. Well, I put 11 up there. That's the reason I got the 11. Alright, of 8 over 15. And I get 28.1 degrees. However, you're going in the clockwise, which is a negative. So that means that A is 17.0 at a minus 28.1 degrees, or to the same 3 sig figs, 17.0 at an angle of 332 degrees if you want to go all the way around to this side. Either one of those would be a correct answer. Number 8. Well, I tell you what, for number 8, we'll stop and do that in the next video.